Hello, we are going to look at a few concepts in this chapter related to amino acids, peptides, and proteins. And the focus is going to be on some of the important concepts that I want you to be acquainted with. It's not going to be a replacement for the lecture notes, but to give you a better understanding of what is involved in this chapter. So, amino acids usually act as the basic building blocks for peptides and proteins. Most of the naturally existing amino acids will have a carboxylic acid functional group, which we call the C terminus, and the amine functional group in the alpha position of the carboxylic acid. So we call that the N terminus. When any two amino acids interact together, the interaction takes place between the N terminus and the C terminus, so they end up forming what is called a peptide bond. So when there are two amino acids interacting, they form what is called a dipeptide. When there are three, they form what's called a tripeptide, in that order. So in other words, when amino acids interact, they form a long chain. If that long chain is up to around 50, we call them peptides. There are 2, 3, 4, 5, up to around 50, we call them peptides. When they're about 50 and above, then we call them proteins. So in other words, proteins are simply longer chains of amino acids, longer than the peptides. The other thing you will realize later is that proteins can actually conform into specific shapes to enable them perform a specific function. For example, to act as enzymes or even to achieve the transport of specific materials in a biological system. But then, how do we synthesize the amino acids? Well, there are three methods by which we can achieve the synthesis. One of them is what we call the HVZ reaction, followed by an SN2 substitution. Now, in this HVZ reaction, followed by SN2, we utilize a carboxylic acid, and then we follow that with excess ammonia. Now, we learned that in HVZ reaction, we can install a halogen in the alpha position of a carboxylic acid. So, using the method we learned before, we can be able to install a halogen, in this case bromine, in the alpha position. Then, in the presence of ammonia, we can do an SN2 to install an amine in the alpha position, so we end up forming an amino acid. The second method involves what we call amido-malonate synthesis. In amido-malonate synthesis, we utilize the alpha proton. So in this case, you realize that it is similar to the malonic ester synthesis. So we have a base that can easily deprotonate the alpha proton, and then we can install an R group. So this process involves installation of the R group. Now the amine is already there. It's only that it is acetylated to protect it from reacting with an alkyl halide or any other group within during the reaction. The carboxylic acid is also already there. So if we do hydrolysis, we can end up forming the carboxylic acid. So these two are already there. The only thing missing is the R group, which we can easily install if we use the malonic ester synthesis like we learned before. And then if we do hydrolysis followed by the use of heat, we are going to transform this portion of the ester into carboxylic acid, and then when we use heat, it is easy to lose the whole of this portion. So we end up with the product that we are interested in. Now, so the key thing is, in a midomalonate synthesis, we already have the carboxylic acid, we already have the amine. The only thing that we need to install is the R group. The third process involves a process that we call Strecker synthesis. In Strecker synthesis, we start from an aldehyde. Now notice here we do not have carboxylic acid, we do not have an amine, so we need to install both. So the only thing we have is the R group. To install an amine and the carboxylic acid, we can utilize two materials. One of them is we need an amine. The amine can be generated in situ if we use ammonium chloride. The ammonium chloride generates HCl plus the ammonia. Then the ammonia, in the presence of the acid, is going to react with the aldehyde to form imine. Once it forms an imine, then now we can introduce a cyanide. The cyanide now interacts with the imine to form the other intermediate, which we can now hydrolyze to give us the product. So the hydrolysis of the nitrile gives us the product, and the amine is already in that position. So two processes. We use ammonium chloride, which forms the imine, and then the cyanide attacks the imine so that we end up forming a nitrile, which we hydrolyze into the product that we're interested in. Now notice that all the three processes we have learned involve the formation of racemic mixtures. So in all these cases, we end up with either the R or the S because of the stereochemistry in the alpha position.